Hello, my name is Gabriela Ramos, and this is my bonus project for Fluid Mechanics Spring 2023. So I'm just starting off by pulling up my third fluids project, and I'm just going to make some alterations to my velocity because we were given different parameters for our Reynolds number. And yeah, so let's get started. I'm going to first open up my solutions. Okay. And I'm also going to open up my results because those are the two places where I'm going to be making changes. Okay. Okay. So first I'm going to start off by turning this off because we really won't be needing it. The first thing that I'm going to do is I'm going to create some expressions to represent both my theta and my CP, which are the values that we're interested in looking at when creating our table. So I'm going to go ahead and create new. I'm just going to name this CP. I'm putting OK. And the expression for this, bear with me as I look at my notes, is going to be pressure. And as you can see, it recognizes it as a variable. I'm dividing that by 0.5 times my pressure times my velocity of every single simulation that I decide to run. And I'm just going to go ahead and put my first one for my Reynolds number of 1 times 10 to the fifth. Negative fifth. And I'm applying. And I'm going to go ahead and make a theta. And this is going to be a cosine of a negative capital X divided by 0.5 bracket and apply. Now I need to associate these with some variables, and at first I had named them the same thing, but it won't allow you to do that. So let's put number 1. And the expression should be CP by, and you go ahead and do the same thing for theta. And theta, and apply. Okay, perfect. Then I'm going to come over here, and location, I'm going to do polyline, because this is where I'm interested in finding these values. Remains, and surface, boundary intersection. I'm doing the wall, and I'm doing the symmetry. And apply. Let's make sure it's right here. Okay, and apply. Perfect. So we can take a look at what that looks like. Okay. Now I'm going to go ahead and I'm going to make a chart. And this is going to be my theta versus my CP. I'm gonna go data series. The location should be that polyline that I just created. And then my x-axis, I'm gonna click on these 3 dots so that I can get that new, those variables that I created. So my x is gonna be my theta, and my y is gonna be my CP. And apply. So that's from doing nothing. Okay. So now I'm interested in viscid flow to start. So I'm going to model viscous. I'm changing this to inviscid. I'm clicking OK. I'm coming to my boundary conditions. This doesn't really matter because when you do inviscid flow, you're assuming that your viscosity is infinity, but I'm going to go ahead and put my first one so that I don't have to change that later. Um, then I'm coming here to methods. I'm changing this to coupled and this to second order. And I believe that's it, but I might be missing something, so bear with me. Mhm. Right, so I use my density as 1.225. So create a change, and close out, and make sure that this goes in. Okay. Let me go to initialize. There it is. I'm computing from the inlet, and my y velocity should be 0. I'm initializing and running. Alrighty, and let's go look at that in post. Yes, I would like to refresh. And voila, myself up. Perfect. So that's close enough to 1, I would say. And I've already exported all of these because I did this prior to my recording. But when you were to export, you want to make sure that you're exporting this chart data. So you click here at the bottom, export, and you can call it what you want. I called it export inviscid. And now I'm going to go ahead and change that and have my Reynolds number be equal to 1 times 10 to the 5th. So I'm going to come back to my fluent. I'm making sure that my model is no longer inviscid. Apologies. I'm selecting K epsilon. Okay. I'm coming over here to my inlet and making sure that my velocity is 1.47, which is what I had from my hand calculations, which I will include in my report. I'm going to my methods and I'm changing this back to what I had originally, which is simple. My pressure is presto. And I'm just initializing and calculating. Okay. And because I had already set up in my pressure, in my CP expression, my velocity as 1.47 to the squared because I had anticipated that I was going to use that value, I don't have to change that beforehand. Then again, you get this, and you're going to go ahead and click export, and I called this export 1 Reynolds. Okay, moving on to my next Reynolds number, which is 2.6 times 10 to the 5th. I'm going to my expression, and I'm making sure that I'm changing my velocity in this equation, or expression, my bad. And the value that I got from my calculation is 3.82, and I'm applying. I'm going to my fluent, and I'm making sure that I'm changing the velocity over here as well. I'm applying. Click one more time just in case. Closing. But everything else should remain the same. So I'm initializing and calculating. Okay, perfect. Yes, I would like to update. Cool. And we should be hitting outline. Make sure that we're in our chart viewer, and then we can export. And I've already got mine right here. So now I'm going to go ahead and do that for my new Reynolds number of 8.5 times 10 to the fifth. I am changing this value over here to 12.49. I'm applying, going over here, and making sure that I'm also changing my velocity here as well to 12.49. Apply, close that out, and I'm initializing and calculating. Okay, coming over here, clicking yes to have that refresh. Alrighty, making sure that we're on outline with the chart viewer so that we're able to export. And here is mine. Now I'm going to go ahead and do my final Reynolds number, which is 3.6 times 10 to the sixth. And I was a little bit scared because my velocity was so high, but I was told that as long as it's under 100, that things should go just fine. So from my hand calculation, I had my velocity come out to be 52.9. And in case I didn't say this earlier, I'm using my diameter is 1 meter. And as my viscosity, I have 1.8 times 10 to the negative fifth. I did not use the value that is default on ANSYS, but I rounded off because that's what I used for my third project. So I'm applying this, making sure that I go back here. Let me just double check. I know I just did that, but just in case, line close and initialize and calculate. Ready? Yes, I would like to refresh. Making sure I'm on outline, chart viewer, and I'm exporting. And here's mine. So as you can see, all of these were downloaded individually as CSV files, but what I went ahead and did so that I could have all of those values on one table alone is I simply copy pasted all the CP values from each individual Excel and I uploaded it to the first one, which is my Invisid. All the X values should be the same because we're working within the same range. And so I went ahead and did this. Scroll up, all the way up, lots of values. I have this is my theta. These are all my CPs. These are my different Reynolds and scenarios. And I formatted it as a table. At first, I did have some confusion because I was like, oh, there's two lines. So I went ahead and I tried to delete any duplicates, but that didn't seem to fix the issue. Um, I'm selecting the entirety of the table. And then I click this little icon right here. Oops. Oops. If it'll let me do it. I click that little icon right there. I'm going to, I'm sorry it's in a different language, but I'm going to more graphics and I'm selecting this option over here. I did have some formatting issues. I had to get my, initially I had no titles, but a proper chart does have titles. So, and labels. So this was over here in the center. I pushed that down, made sure that all of my lines have a solid label and that it was reflective of the image that was provided to us in our guideline document. I gotta give credit where credit is due, so thank you to YouTube for helping me out with this project. But I hope you enjoyed, and thank you so much for watching.